Continuing lesson 3.1 on analyzing percents of numbers. If you look at page 140, number 3, Gene stated that finding 25% of a number is the same as dividing the number by 1/4. Is Gene correct? And explain. Actually, the answer would be no. Okay. If you divide something by 1/4, remember dividing, you keep change reciprocals. So whatever you're dividing by 1/4, you'd be multiplying by 4. Multiplying by 4 is not the same as getting 25% of something. It would have been the same as multiplying by 1/4, not dividing by 1/4. Okay, so again, same as multiplying by 1/4, not the same as dividing by 1/4. Number 4, an 8-ounce serving of apples contains 8% of the daily vitamin C. How many ounces of apples would you need to get 100% of your daily vitamin C? So if you want to do a proportion here, you can. We're trying to find how many ounces to get 100%. We know that 8 ounces was 8%. This is a very nice pattern here. Remember, we're going to try to go towards our variable, multiplying or dividing. We know going from 8 to 8 would be multiplying by 1. So 100 times 1 would be 100. Okay, so basically each ounce is 1%, so 100 ounces would be 100%. Another option you could do, 8% divided by 8 would be 1% per ounce, and then multiply that by 100. And if we look at number 6, water is 2 parts hydrogen, 1 part oxygen, H2O. For 1 molecule of water, each atom has the atomic mass unit U shown. What percent of the mass of a water molecule is hydrogen? So, different ways we could do this. One option is we could, first of all, figure out how much this weighs altogether. So if we add these 3 together, that's 18 2/2 atomic mass units altogether. The hydrogen, the 2 hydrogen parts are 2 2/2. And then to find the percent, we could just take 2 2/2 divided by 18 2/2. If you divide that out, that'll give you a decimal, which is 0.112. Then you move your decimal 2 places to the right, would mean that's equivalent to 11.2%. One different way, slightly different way you could do this, slightly different option would be, you could say we're trying to find the percent out of 100, and we know we've got 2 2/2 out of 18 2/2. Okay, the 100% is our total, the 18 2/2 is our total, and then this is our part that we have. And again, whether or not that's a great pattern or not, maybe not, but if nothing else, you could say they're dividing by 100. You could multiply by 100 on both sides, and that will actually give you your percent to where you would not have to move your decimal over. That would actually give you the 11.2% when you work that out. Workbook page 33, number 1. A school orchestra has 60 members. 20% of the members are percussionists. So how many orchestra members are percussionists? So what we can do here, basically, the book didn't really show this to you. We kind of talked about it though. We could just say percussionists, it's 20% of 60. 20%, we'll change that to a decimal, which is 0 and 20 hundredths, or just 20 hundredths. And we're taking that times 60 if you want to use parentheses rather than a dot so we don't get confused about decimals. So if you work that out, that would be 12 percussionists. Okay. You know, another option you guys might be able to think about, stuff like 20% is the same as 1/5, if you remember that. So you could do 60 divided by 5 would be another option. Number 3, an item sells for $40. The sales tax on the item is 8%. What is the sales tax and total cost? So first thing we can do is find what the sales tax is. We know sales tax here in this problem is 8%. So we could say that's going to be 8% of the $40. So 8%, we can change that to a decimal, is 8 hundredths. Just moving your decimal 2 places to the left. Or if you want to change it to a fraction first, it's 8 over 100, and then 8 hundredths would be the same as 8 hundredths as a decimal. And then of usually means times. So 8 hundredths times 40, and we get 3.2. So what that means is add a 0 on the end. That's $3.20 for our sales tax. So once we know the sales tax, we could find our total costs. Sales tax is what gets added on. Okay, usually it's a state sales tax that gets added to the price. So if we add that on, total cost would be $43.20. Number 5, number of students in the marching band this year. Is 125% as many as the number of students in the marching band last year. And there were 36 students in the marching band last year. How many are in the marching band this year? So I kind of color-coded this with last year and this year. So we know last year there were 36 students, and this year there are 125% as many as last year. So basically, in a roundabout way, they're telling us 125% of 36. That's how many students would be in marching band this year. So the percent we can change to a decimal, move it 2 spots to the left, would be 1 and 25 hundredths. That means times 36. And if you multiply that, it would be 45. We know 125%, that's more than 100%, so we know we had more than the 36 we had last year. So that's one thing to think about when you get your answer on this problem. Another option on this problem would be finding what 25% is. Basically, 100% is what we had last year. 125%, we've got 25% more. So we got an additional 25%. We could just find what 25% of that is, or if you recognize that 25% is 1/4, you could take 36 divided by 4. Either way, when you do that, you'll get 9. And that means we have 9 more people than last year, which would be a total of 45. Number 6, Joe earns a commission of 5% on the audio equipment he sells, and the store keeps the rest. So he sells a $750 amplifier. How much commission does Joel earn from the sale? And then how much does the store keep? So commission is basically money that you earn based on sales. So a lot of times if you're in a job where you are trying to sell things, commission is used a lot. For example, people that try to sell houses, people that try to sell cars, earn commission. My understanding, I don't think generally that like their whole amount of money that they earn is based off of just selling the stuff, but they would get like an amount of money, and then they would have to sell things in order to make more money. Getting the commission, that would be what would make their job worthwhile for them, I guess. Kind of like waiters and waitresses getting tips, similar idea. They earn a certain amount, which, you know, normally we have a minimum wage. Actually, waiters and waitresses can earn less than that because they are going to potentially be getting tips that would get them above that rate. So they're depending on that. And it's the same idea with these jobs, earning commission. They have to be good salespeople, okay? So in other words, this is a way that businesses can make sure that you don't just have people that are slacking off and not doing the work they're supposed to be doing. If they're doing that, they're not going to be getting commission because they're not going to be selling things. And then they're not going to last very long in that position. So basically for the commission, we're trying to find 5% of 750. So 5%, if you move your decimal 2 spots to the left, that's like 500ths, or 0 and 500ths. Times 750 is 37.5. Since we're talking about money, we can add a 0 on. Would be $37.50. So the question then, how much does the store keep? Well, they sold it for $750. So $750 is altogether the sale. If $37.50 of that is going to Joel in this case for his commission, we can subtract those, and $712.50 would go back to the store, and the remaining $37.50 would go to Joel for making the sale. Number 7, Nixon estimates it will take him 5 hours to finish an art project. It actually takes him 320% of the time estimated. How many hours did it take him to finish the project? Okay, so this is generally what happens. It takes you a lot longer than what you might think to finish something. So basically what we're looking at, it took him 320% of the 5-hour estimate. 320%, we can move our decimal 2 places to the left, is 3.20, or just 3.2 if you want, times 5. And if you work that out, it would be 16. So it means it would take him 16 hours actually to finish the project. Don't procrastinate. Number 9, a bike shop sells you a bicycle for $63 and a helmet for $21. Total cost is 150% of what the shop spent originally. How much did the shop spend originally? So one thing we would want to do on this problem would be to add the 63 and 21 together to see how much we paid all together. Would be $84. Most of the problems we've done so far, we would then take 1.5 times 84. If you do that, you're going to get a number bigger than what we spent. Well, if the amount the store charges you is less than what they're paying for it, that's not going to work. They're going to go out of business. So that's actually going the wrong direction. One option here, going back to kind of what the book was showing you guys, one option is to do a proportion. So 150%, we're going to compare that to 100%. The 100% is going to be like the original cost here. The original cost is supposed to be, okay? So the original cost is what we're trying to find. $84 is what our cost was, okay? Which again equates to that 150% of what it costs at the store. So this problem, we can look for a pattern here going towards the variable. So if we go from 150 to 100, so if you take 150 divided by 100, it would be 1.5. The question, are they multiplying or dividing? Well, the number is getting smaller, so they're actually dividing by 1.5. So if you take 84 divided by 1.5, that would give you what the cost was for the store, which should be $56. So $56 it cost the store, and then they sold it all to you for $84. Again, they have to sell it for more than what they bought it for. They're going to go out of business. They have to pay their workers. They have to pay for the electric bills, all those things. Okay, so it only makes sense that they're going to sell it more than what they bought it. Okay, and then part B, how much profit did the bike shop earn? Profit is basically how much they sold it for more than what they bought it for. So we'll just subtract those, and we could see that would be a $28 profit. Number 12, Kevin's car can go 315 miles on 1 tank of gas. He used just under 40% of a full tank of gas to get to a sporting event, traveling an average speed of 60 miles an hour. About how long did it take him to get there, and how did you decide? So a couple steps we have to do on this one. First of all, we're looking at how much gas he used. So it's 40% of the 315 miles for the full tank. That's going to tell us how far he went, which would be 126 miles. Okay, the question wasn't how far did he go, the question was how long would it take for him to get there. So there's a formula that's kind of commonly used in a situation like this. It's called rate times time equals distance. The rate is like the speed you're going, so 60 miles per hour. The time is what we're trying to find, and its distance is 126 miles. So to solve for t, we can see they're multiplying, so we would need to divide by 60. Kind of makes sense. We're seeing how many 60s there are in 126. If you divide that out, you get 2.1, which would mean 2 1/10 hours that it would have taken for him to get there. Number 13, a large university accepts 70% of the students who apply. Of the students the university accepts, 25% actually enroll. So if 20,000 students apply, how many actually enroll? A couple steps here then. Basically, first of all, we could look at 70% of the 20,000 would actually be accepted. So that means 14,000 would be accepted. once we figure out how many were accepted, we could see how many enroll. So 25% of those people actually enroll. Okay, the other ones, you know, maybe this was their backup school in case they didn't get into another school. They decided to go somewhere else. Okay, so 25% of 14,000 would be 3,500 that actually enroll. Number 14, Christine has a weekend job advertising an upcoming play. She has two options. Option A is $7 an hour. Option B is 5% commission on all money made at the play. So if she's going to work 8 hours each day, Saturday and Sunday, she estimates the play will make $2,100. Which option gives her more earnings? So option A, we could look at, it's 16 hours, $7 an hour, would be $112. Option B, 5% of 2,100 would be $105. And that's it, just $105. So actually would be better with option A. So this gives you an idea of analyzing percents of numbers.